Right, okay, so last lesson, as I said, we did the two experiments. We changed the unbalanced force and measured the acceleration. And we said as the unbalanced force increased, the acceleration also increased. Okay, page 13. And then we also changed the mass of the trolley. And we said as the mass of the trolley increases, the acceleration decreases. Okay, so page 13 says these two experiments give us two conclusions that can be combined together. A, and remember that squiggly sign means it's proportional to, so as one goes up, the other goes up. So A is proportional to F, where mass is constant. So acceleration goes up if force goes up. But A is proportional to 1 over m, so that means if acceleration goes up, mass goes down, okay, where the force is constant. And if you plotted the graphs of those, acceleration and force, you'd get a straight line through the origin. And if you plotted, which we didn't do, acceleration versus 1 over mass, you'd also get a straight line through the origin. We plotted acceleration versus mass, so we got a decrease. Okay. So if we combine those two, acceleration is proportional to force over mass. Okay. So rearranging that, you can just sort of treat that as an equal sign when you're rearranging it. Then force is proportional to mass times acceleration. And if something is proportional to something else, you can say it's a constant times by that something else. So force is a constant, we just call a constant k, usually in physics a constant is just k, times by mass times by acceleration. Okay? And in our case, in this case, the constant is nicely 1. So it's just F equals 1 times ma, so F equals ma. So if mass is measured in kilograms and acceleration in meters per second, then force is measured in kilogram meters per second. So remember the units are just the values combined. And 1 kilogram meters per second squared is known as 1 Newton. And so the units of force is newtons. Okay. So we end up with the equation, and this is Newton's second law. Force is mass times acceleration, where force is in newtons, mass is in kilograms, and acceleration is in meters per second squared, so meters per second, ms to the minus 2. We're going to do some examples using this equation. We're going to start off relatively easy and we'll progress to slightly more tricky. Okay. And the trick, again, as is with most equations, is write down what you know in the question and then pop the numbers into your equation. So, example 1. A child pushes a toy car of mass 100 grams with a force of 2.0 newtons. Calculate the acceleration of the car. Okay, so what do we know? The mass is 100 grams, but it's in grams. We need it in kilograms, yeah, excellent. So that's 0.1 kilograms. The force is 2.0 newtons, and we want to know the acceleration. Well, we know the equation is F equals ma, and remember, good exam technique to write down the equation given to you, so F equals ma. Okay, I know we're looking for acceleration, but we write down the equation that's in the equation list first, without rearranging it, then we put the numbers in, and then we go about rearranging. So, 2 equals 0.1 times by acceleration. So acceleration is going to be 2 divided by 0.1, which is 20 ms to the minus 2. one was quite a nice one. Got some more to go. In fact, you guys have a go at example 2. You have a go and I will go through it once you've had a go. So write down what you know, write down the equation, put the numbers into the equation. Yeah? What do you mean, what letters? You could say, or do you mean like what would you, like you could say it's forward force and backwards force, FF and FB if you wanted, or something like that. Is that what you're asking? Yeah. Oh, F or F unbalanced. So, like, or F overall or something like that. Yeah, that's what I use. Yeah. So hopefully you've got the answer of 7,500 kilograms. Has anyone not got that answer and not sure where they've gone wrong? Okay. Right, so example 1 and 2, straightforward. Here are the numbers, put the numbers into the equation. Example 3 is a little bit more complicated. So, a car engine exerts a steady force of 2,400 newtons on a car of mass 800 kilograms. The force of friction on the car is 400 newtons. Calculate the acceleration of the car. Right, so I always like to start these with a little diagram. Okay, so you've got a car, it doesn't have to be a perfect image of a car. There we go. And it's 800 kilograms. And we've got a forward force of 2,400 newtons. But we've also got friction, which acts in the opposite direction, of 400 newtons. We want to find the acceleration. So F equals ma is actually, the F that you use has to be the overall force, the unbalanced force on the object. Okay, so you have to put in the unbalanced force in F equals ma. So the overall force, the force that comes out at the end. Okay, so I'm going to write it down as unbalanced force, so F-U-N. So F with a little un. And you could put it straight into the equation, but I'm going to do it step by step just so you can see when you come to revise where it's come from. Unbalanced force, so force with a little un next to it. Okay? So the unbalanced force here, remember it's got 2,400 that way, 400 that way, so the overall force is going to be 2,400 take away 400, so 2,000 newtons. And that is what we put into F equals ma. Okay? So you need to be careful with these. If you've got two different forces acting in different directions, you have to find the overall force first. Yeah, it be the biggest minus the littlest, yeah. So F equals ma. So 2,000 equals the mass times by the acceleration. So acceleration is 2000 divided by 800, which is 2.5 meters per second squared. Is that clear? That is really important you remember that, because quite often in exam situations, the pressures of exam situations, a lot of people just go, right, 2,400, it's the force. Yeah. So you need to just be careful and read the question fully. Yes, I can.
So if the forces were split and the 400 was that would be still be the same as?
Yeah, but it would be going in the other direction. Yeah. The only different answer you come across is if they're both acting in the same direction, then you'd have to add them. Yeah. Right, B. If the car engine suddenly cuts out, so the forward force goes down to 0, calculate the acceleration of the car assuming the force of friction is still 400. So this one, we've got our 800 kilogram car, but this time we've got 0 forward, and we've got 400 newtons back the way. So our unbalanced force, as Finlay rightly pointed out, would be 0 minus 400. Then you'd use F equals ma. So minus 400 equals 800 times the acceleration. So the acceleration will be minus 400 divided by 800, which would be minus 0.5 meters per second squared. Which makes sense, doesn't it? Because if the engine suddenly cuts out, the acceleration will be negative, it'll be decelerating, be slowing down. Okay, so as I said, it starts off really easy. I don't think it's difficult, but there's a little bit extra thrown in. And the next example, there's even more extra thrown in. But again, I don't think it's difficult. I think it's just there's extra you need to think about. Okay, so example 4. Just try and ignore it. Has everybody finished this? Can I move on? Okay. A firework rocket of mass 2.5 kilograms, guys. James. Is launched vertically upwards from the surface of the Earth. Its motor exerts a thrust of 95 newtons. Calculate A, the unbalanced force on the rocket. So again, I like to draw a little diagram, and my rockets are really bad. There we go. So we've got, there you go. Right, we have got an upwards thrust of 95 newtons. What is the force downwards on that rocket? Well, it's got something to do with 9.8. Yeah, it's the weight. So you have to work out the weight of the rocket, which is coming down. So the mass of the rocket is 2.5. And obviously, gravitational field strength on Earth is 9.8. So the weight of the rocket is 24.5 newtons. So therefore, the unbalanced force is 95, take away 24.5. Okay, so they haven't told you the force backwards in this one. They haven't told you the opposing force, so you've got to work that out. So you've got to remember the downward force on something that's going up is its weight. And part B is just using F equals ma again. So the unbalanced force the mass times by the acceleration. The acceleration is 70.5 divided by 2.5, which comes to 28.2 meters per second squared. Just got a little bit more to go through, and then I'm going to get you guys to do loads of questions on these. Loads. Okay, just to let you know as well, I will be setting you a homework tonight of a multiple choice sci-fi quiz on Newton's first law and Newton's second law. So these kind of sums, and also the Newton's first law that we've done already. Okay, I'll let you go back and look at them if you're not sure. Right, okay, last couple of pages. Sorry, we're still writing, I'll leave that for a second. Have a read through page 16 if you have finished. You got it, Gregor? So it's basically if there's balance forces, stationary or constant speed. Very easy. Right, okay, everyone wrote that up? Okay, so we've already sort of touched on this already. So adding forces. So when two or more forces act on a body, their combined effect depends on the size and direction of the forces. So when the forces act in the same direction, then the total or the resultant or the unbalanced force can be found by adding them together. If they act in opposite directions, they'll be found by taking one from the other. So you've got one positive, one negative. Okay, so that's F1, and that's in the opposite direction, so that's negative F2. So it ends up being F1 minus F2, okay, which gives you the unbalanced force. If they are at right angles, then the unbalanced force is found using Pythagoras' theorem. Okay, so if you've got something going in this direction, something in like that direction, like that, then your unbalanced force would be somewhere in the middle, wouldn't it? It'd be pulling it sort of in the middle. Okay, so you can find that unbalanced force, so it would be sort of in that direction. So you can find that unbalanced force by using Pythagoras' theorem. So if you want to find F total, it'd be F total squared equals F1 squared plus F2 squared. Is that ringing any bells? Pythagoras' theorem. So the total, Finley, I'm writing this down for your benefit. So total would be the square root of F1 squared plus F2 squared. Sorry? You might need to do this for some of the questions, yes. Okay, so page 17 is an example of this, Finley. So we can go through one. So, example 5. A box of mass 2.5 kilograms is acted upon, I don't think this should be, is launched, is acted upon by two forces. The first force pulls the box north with a force of 4 newtons, and the second force pulls the box east with a force of 3 newtons. Calculate A, the unbalanced force in the box, and B, the acceleration. So, we've got this box of 2.5 kilograms, and we've got a force north of 4 newtons, and a force east of 3 newtons. Okay? So, yeah, to find the unbalanced force on the box, we've got basically, if we do tip to tail arrows, we want to find this unbalanced force. That's the unbalanced force. So the unbalanced force squared is 4 squared plus 3 squared. Some of you may realise already that this is one of those typical triangles, 3, 4, 5 triangles. If you don't, that's absolutely fine, just work it out. So unbalanced force squared will be 4 squared plus 3 squared, which is 25. The unbalanced force is 5 newtons. Yeah, square root it at the end. And then B is just what you've been doing all the time, F equals ma. But remember, you have to put the unbalanced force in. So in this case, it's 5 equals 2.5 times by acceleration. So the acceleration is 2 meters per second squared. Okay, as I said, there are lots and lots of these questions because I can pretty much guarantee that at some point you're going to make a mistake and you're going to forget about your unbalanced force, or you won't have used one of the forces involved. So, in your question booklet, page 6 to 16 are questions on this. Obviously, I'm not going to ask you to do all of them, but I want you to make a start on them. And as I said, your homework is a multiple choice quiz on Firefly. I haven't set it yet anyway.